Hello, I'm Shenzhen. The topic that I'm presenting today is about the learning behavior of neural network in image classification. So we investigate it from a frequency shortcut perspective. You may wonder what are shortcuts. In classification, they are decision rules based on spurious correlation between data and ground truth. They could be visual cues, such as the text appearing in the figures, which is the most distinctive feature for classifying a horse. So, which makes us wonder, is there similar behavior in frequency domain? So we look into the literature of frequency analysis about the neural network and discover that most work focus on regression tasks and discover that there exists a low frequency bias in the early training stage. And classification, they mainly focus on investigating the frequency importance to classification, which also makes us wonder, is there such a frequency bias in classification tasks? So in our work, we studied these two perspectives and broaden the understanding of shortcuts in the frequency domain. In summary, we investigate the frequency learning of neural networks at the early training stage and what frequencies are used at the end of training, which uncovers frequency shortcut learning. So for example, in these figures, you can see that given such a limited amount of frequencies, the models can still correctly recognize the two figures in the right column, which is actually a sign of frequency shortcuts learning. So we first investigate the data characteristic and relate it to the frequency learning early in the training. We devise an algorithm called ADCS. This is to compare the frequency characteristics of image in a class-wise manner, which brings us to this colorful map for each class. And the blue colors at a specific frequency just simply means that this class is on average has less energy than the others, and the right just the red color is just another way around. So we now observe that the classes hummingbird and zebra, they have quite outstanding frequency characteristics. So we want to see and test the models whether they use such characteristic early in training. So we evaluate the performance of the models trained for the first few iterations, and now we observe that the precision of zebra and the recall of hummingbird are in general higher than the others, which means they are learned faster than other classes. So we actually observed that neural networks can learn either low frequency or high frequency at the early training stage for classification. It is just dependent on data characteristics. So now we observe that such outstanding frequency characteristics can be used early in the training, but will they further be used at the end of training? So we develop an algorithm to evaluate frequency importance to the classification, and the most important thing is it can examine shortcut learning behavior. The algorithm is based on frequency removal and loss changes recording, and the changes of the loss value will be used to rank frequency importance. So by selecting the top X% frequencies, we can obtain DFM for each class. And this is not the end. We need to test the specificity of the frequency sets to classification, and which turns out that zebra is indeed one of the classes using frequency shortcuts. So a typical provided here. So if we feed the model with a woman wearing zebra pattern clothes, it could be predicted as zebra with super high confidence. But if we feed the model with a horse image, it is just simply misclassified, even if it has a similar shape as the zebra. If we mix these two figures together, like even just with 40% of the zebra clothes image, the confidence values of being predicted as zebra is improved significantly. So indeed, you can see that now the models are relying textures over shapes, which impair the generalization ability of the model. So far, we see that frequency shortcuts, they are driven by data characteristics, and they can impair generalization and create an illusion of better generalization. We also provide some more observations regarding the effect of model capacity and data augmentations on frequency shortcut learning, and how frequency shortcuts can be transferred among data or models. We also give an outlook on designing augmentation techniques which target data characteristics. For example, using the DFM that we developed. So thank you.